Good evening. I'm Calvin Joseph, and I'm going to conduct the week 10 problem solving and doubt clearing session for the course Electrical Measurements and Electronic Instrumentation, which is taught by Professor Abhishek Chaturvedi of IIT Kanpur. So the outline is I'm going to talk about why we need electronic measurement. Why not just simply the basic voltmeter, the basic ammeter, which we have, why we just cannot use them all the time. Okay. Then I will talk about voltmeter and ammeter characteristics. What is the advantage of using both? Like what we want, an ideal voltmeter, how it should behave, how it should respond, etc. for the voltmeter and ammeter. Then we will talk about how voltage and current measurement we can do using amplifiers. We'll also talk about how, like if we have an AC voltage or AC current that we want to measure, but we have a DC measuring instrument, then how we can use some suitable rectifier and some suitable mapping, etc., so that we can do our measurement which we want with some constraints. Okay. And then we will also look at some example sums. So we'll start with the week 10. Okay, so we have almost come to the end of the course. We have studied various things. We have studied voltmeter, ammeter. We have studied errors. We have studied various types of measurements, power measurement. Okay, how do we measure power factor? Then how do we measure resistance, inductance, capacitance? So we are measuring a whole lot of things. Okay, then finally we learned how do we measure frequency, how do we use digital circuits, etc., measure frequency, etc. We also studied some bit of amplifiers. Okay, now in this session we will focus a lot on amplifiers and why we need them. Okay, so why is there a need for electronic measurements? We know for voltage measurement, we will use a voltmeter. Okay. Voltage measurement, we use a voltmeter. So we have some circuit and we have some sort of resistance, inductance, something we have. Okay, we want to measure a voltage across it. So we will connect a voltmeter. Okay. And ideally, what should be the resistance of voltmeter? How much should it be?
0, sir.
The voltmeter resistance should be 0. Why? If your voltmeter resistance is 0, then this is like a short circuit, right? So this entire voltage will become 0, which is not correct.
Infinite होगा sir. Ideal case में infinite होगा.
Infinite, yes. So it should be infinite. It should be infinite. Okay, it should be very high. So that there is suppose some current which is flowing earlier, I1. This current I2 should be 0. For that, this internal resistance should tend to infinity. Okay, it should be very high. But is that possible in our practical circuits? In our practical circuits, this is not possible. It is not possible that the resistance of your voltmeter can be infinite. Okay, and that it should be able to measure very accurately your voltage at very low voltages also, whether it can give you accurate readings. That is also an issue. Okay, so for that, what do we do is, like suppose this voltage is, let's say, around 1 volt, and we have a voltmeter is from 0 to 100 volt. Okay. So that means on that scale, this is 0, this is 50, this is 100, this 10, 20, 30, 40, 60, 70, 80, 90. It's not uniform, but you get the idea. So 1 volt will be somewhere over here. And when we look at it, we may think it is 2 volt, we may think it is 3 volt, etc. We will not accurately know what is the exact value. Okay. When we look into the voltmeter display, we may look from a pal, we should look straight. We may look from some angle. At some angle, it will look either 0 or 2 volt. Very rare, it is very hard for us to exactly know what is the voltage. Okay. So also at low voltages, the relative error is more. Okay. The relative error is more. Suppose my voltage, true voltage, is like say 1 volt. But because of error, I will measure it to be 1.1 volt. So then that error is because of the instrument is not properly calibrated, etc. Some issue. So my error will be what? My V true minus V measure, the absolute value, upon V true into 100. So that comes out to be 0.1 upon 1 into 100. It comes out to be 10%. Okay, it comes out to be 10%. So that is a very large amount of error we are seeing. But if my V true, let us say, was 99 volt, and the measured voltage is actually, let us say, 99.1 volt, same amount of error, we may think. But the percentage error, which we will have in this case, is V true minus V measure upon V true into 100. So that is again 0.1 upon 99 into 100. So it is roughly 0.1%. Okay, it is roughly 0.1%. That is why they say that when we are using a measuring instrument, we must use it at its range, at its topmost range. There, the relative error is less. Okay. So now what should we do if we want to measure very low voltage? We want to measure very low voltage, but it is creating an issue if we use a voltmeter. So any idea what should we do? So what is done is we require what is known as amplification. We want to amplify. So the amplifier is a very interesting topic. Like yeah. So one easy example is the speakers. Okay. So someone has a mic, they speak into a mic, it goes to your speaker, it goes to your amplifier, etc. And then it goes to your speaker. So your amplifier will increase the power which is there in that voice signal, and then the speaker will send out that signal. So it will be very loud. So you may talk very softly, but the speaker will send it with so much of power that it can be heard very far away. Okay, so that is the power which comes because of amplification. We are increasing the level of the signal. So what we do over here also, the low voltage, very low voltage, is amplified. Okay, it is amplified. Okay, using op amps. So here you will understand why op amps, where do we practically use it, how it can help us. Okay, so we will go to the next page. We know the non-inverting amplifier, right? How does it work? This is the positive terminal, negative terminal. This is my R2. This is my R1. This comes over here. And this is my input voltage. And this is my V out. So your V out is actually 1 plus R2 by R1 into V in. This is the gain. Okay. So let us say my input voltage, let us say was 1 millivolt. And my R2, let us say it was 99 kilo ohm. And my R1, it is 1 kilo ohm. Then what will be my V out? Can you tell me? What will be V out in this case? How much?
100 millivolt, sir.
It will be 100 millivolts. Okay. Or it will be 0.1 volt. Okay. So that's how a very low voltage can be amplified. It can be increased to some value. 0.1 volt also is something which we can measure. This is your minus V supply. This is your plus V supply. Okay, so all these are there. So any queries in this?
No, sir.
Okay. So then at the output over here we can connect a voltmeter. Okay, and so your voltmeter will then show you 0.1 volt. But that voltmeter should be a very low voltage rating. Otherwise it cannot go. Which I showed. So let me say instead of 1 millivolt, let my V in be 0.1 volt. Then what will be my V out? If V in
10
is
volts, sir.
so your V out will be 10 volt. Okay. And your voltmeter, its full scale range is 0 to 10 volt. So it's your maximum deflection. So even though
Yes,
my
sir.
signal actually is 0.1 volt, I can measure it to be around 10 volts. And then I can back calculate. I can say whatever reading I am getting, I have to divide it by 100. That will be the true voltage which is actually there. True voltage which I want to measure. Okay. This is with respect to the ground. Okay. So suppose, let us say my input signal was something like this. And my gain of my amplifier was, let us say, 5. So how will my output signal look like?
Five times होगा सर इसका.
Okay, the output signal will look like this. Okay. Will look like this. So it will be in phase. Okay. This is your V out. This is your V in. So this is the way this small signal can be amplified to a large signal. Okay. But now this is AC voltage. So how will we measure AC voltage if I have a PMMC instrument? So what does PMMC instrument measure?
RMS value, sir.
Huh?
RMS value, sir.
Kind of RMS, but PMMC.
No, sir, DC.
Yes, PMMC instrument can only measure DC. Okay.
DC
But,
तो average value ये करेगा.
yeah, it is measuring the average value.
Yes, sir. Yes,
But
sir.
your moving iron and your electrodynamic,
ये RMS का ये करेगा.
no, these instruments will measure RMS because it is the
Yes.
square of the current. So the average of the square is your RMS value. Okay. So that's the thing. So now, why I want to use a PMMC instrument? So can PMMC instrument, what advantage it has over this moving iron and electrodynamic instrument? Can you tell me what you remember? Sorry? You can tell again, I couldn't hear. So one advantage is it has a linear scale.
Yes, sir.
This is one of a very big advantage. Another advantage is it is more accurate, kind of. So now I want to use these features of my PMMC instrument and I want to measure AC voltage. I want to measure the AC voltage. So what should I do then? Because if I give this signal, my PMMC instrument, which is finds the average value, will give me 0 volt. Okay, it will show 0 volt. Then what should I do then?
Rectifier use करेंगे sir.
So I need to use a rectifier. Okay, I need to use a rectifier, and that will help me to measure AC quantities. Okay, let us go. Okay, rectifiers have two types. We have what is known as a full wave rectifier
Already half wave और full wave.
and half wave rectifier. Okay. Suppose I have my input. It is AC. I have a diode and I have a resistor. This is my V out. Okay. So now my input voltage is changing like this. Okay. We will assume that diode drop is 0. Just for making it simple. Okay. How will the output voltage look like?
Positive cycle measure करेगा, negative cycle 0.
So during positive cycle, the voltage will be positive. Then it will be 0. Again in positive cycle, it will be positive. Okay. So this is my V out. This is my V in. What will be the voltage across the diode? So when the diode is conducting, the voltage drop is 0. Okay. And when it is not conducting, it will block the voltage. Yeah, threshold voltage. I consider threshold voltage is 0. And then it will be stuck like this when it is conducting. So this is the voltage across the diode. So it has to obey KVL. Your V in is equal to your V out plus VD. So in this case, your VD is 0. So your V out is equal to VN. In this case, your V out is 0 and your VD is equal to VN. Okay. So that is something you must consider. Now, in case the diode had a drop, In case the diode had a drop, it would have some voltage like this over here. Some voltage it will have. Okay, this is your diode forward drop. Over here, it will be as it is, because it is blocking. Then here, when it is conducting, it has some constant voltage across the diode will be there. What will happen to your V out then? Your V out will not rise until it crosses it. And then it will be a little bit smaller. Okay? Will be at 0 over here. It will be somewhat smaller. Okay, so that will introduce some sort of error. Okay? For the time being, let us ignore that error. So what is your average value of V out? What is the average value of V out? What is its average value? If it is in this form, if your signal is like this, here, like this is your V out, this is your V peak, then what is your average value? How much is it? This 0, pi, 2 pi, 3 pi.
V peak
How
by
much is your average? How much?
V peak by pi, sir.
V peak by pi. Okay. So this is a very important relation. So it's advised that you remember it. Now, we'll consider another circuit. This is your input. Then there is this full wave rectifier. Okay. So when your wheel is positive, how will your current flow? Your current will flow like this, and like this. This is the flow of current. But when your Vin is negative, then your current will flow like this, like this, like this, like this, and like this. So in both cases, your current over here is always flowing like this. So your V out is always positive. And that is what we want. Okay. So now, if this is how my input signal is varying, my output signal will look like this. Okay. This is your V out. This is my VL. Okay. So what is the average value of V out? Assume this is V peak. What is the average value of V out? Hmm?
2 into V peak by pi.
Yes, it is
Right,
2
sir.
V peak by pi. Okay. So this is the trick. Which you must know. Now I want to find the V in RMS. So how will I find V in RMS then? So my V out average is measured using a voltmeter. Now I want to find the input RMS value. How will I find that? You know my V in RMS is equal to root 2 into V peak. Sorry. It is V peak
Repeat by root 2.
root 2. So my
Yes.
V in RMS is equal to pi by 2 root 2 into V out average. Okay. So then my actual RMS voltage is equal to pi by 2 root 2 into my voltmeter reading. Okay, that is how I can use what is known as a rectifier and measure the RMS value of an AC voltage. Even though I just have a PMMC instrument. So any doubts still here?
इसमें जो वोल्ट मीटर का रीडिंग देगा वो आरएमएस वैल्यू है
नहीं, वोल्टमीटर रीडिंग मेरा एवरेज वैल्यू दे रहा है और वो एवरेज वैल्यू को मैं आरएमएस वोल्टेज में कन्वर्ट कर रहा हूँ इस फॉर्मूला से।
बाय कैलकुलेशन पर।
हाँ भाई, कैलकुलेशन करना पड़ेगा।
ओके।
So now we understood how to measure the RMS value, how we can use a rectifier, etc. Now we will consider the scales. So I have my non-inverting amplifier. R2, R1. This is my VN. This is connected here. This is ground. Then I will have a diode. Okay. And then this is my load. And then I have to find my V out. Okay. Assume VN is AC. So over here, what will be the voltage? Over here at Vx, Vx will be equal to 1 plus R2 by R1 into Vn, right? Vx is 1 plus R2 by R1 into Vn. But what is my V output? V output is equal to 0 if Vx is less than 0. Because if Vx is less than 0 means your diode is reverse bias. So yeah, so no current will flow. So the current here will be 0. So your output voltage will be 0. Okay, that is one thing. Next, assume your Vx is greater than 0. Okay. And your Vx should be greater than the drop. There is some drop which comes over here. So your Vx should be greater than Vd. If your Vx is greater than Vd, then your Vout will be what? Your Vout will be equal to Vx minus Vd. So your Vout is equal to 1 plus R2 by R1 into Vn minus Vd. So this will introduce an error. Okay, this will introduce an error. Okay. Okay. So any doubts in this?
No, sir.
Okay. So now how do we overcome this problem? There is a easy solution which sir has taught. What we do is we just make a slight modification. This is my input, remains the same. This is my R2, this is my R1, and the diode is moved from here to here. So this becomes my diode, and this becomes my R load, and this is my V out, this is Vn. Okay. So now what happens is, because of virtual ground, this actually is Vn. Okay, this actually is Vn. So what will happen? What will be V out? If Vn is greater than 0, then my V out will be equal to V into 1 plus R2 by R1. Okay, my V out will be equal to V into 1 plus R2 by R1. It is fixed. It doesn't change. Now, if my Vn becomes less than 0, then my output also will become 0 volt. It will become 0 volt. So why do you think that happens? What could be the reason?
डायोड रिवर्स बायस है बेसिकली।
ठीक है, तो डायरेक्ट रिवर्स बायस हुआ तो क्या होगा? Hmm? So we will check simulations. So for this, we will see what the simulation will tell us. How, what will happen in this kind of circuit. We will refer to simulations to try to understand. Okay.
Okay.
So any other doubts till now? Something you want me to repeat? Okay, if not, then we will proceed further. Okay. So let us consider programmable amplifiers. Programmable amplifiers means what does it mean? We want to be able to change the gain. Okay, gain can be varied. Okay, the gain has to be varied. We know for a difference amplifier, this is my relation and this is the gain. Okay, the gain for a non-inverting amplifier is 1 plus R2 by R1. This is my gain. Now, if I want to change the gain, what I should do? I should change R1 or I should change R2. Either one of them I have to change. Okay. So we want a gain that can be changed. Okay. So what do we do in that case? This is my amplifier. This is my V in plus minus. So this is R2 and this is R1. So instead of just using one R1, we will use multiple R1s. Multiple R1 can be connected. Okay. multiple R1 can be connected. Let us say this is some resistance R. Like this is R by 2, this is R by 4, R by 8, this D0, D1, D2, D3. Okay. And these are all connected to the ground. So when D0 is 1, that means 1 R is connected. That is R is connected. D0 is 0, that means R is not connected to the ground. So in that case, my V out is equal to V in into 1 plus R2 upon R into D0 plus R by 2 into D1 plus R by 4 into D2 plus R by 8 into D3. Okay. So in that way, I can vary the gain. Let us assume, to make life easy, let us make R2 is equal to R. Then my V out is equal to V in into 1 plus 1 upon D0 plus D1 upon 2 plus D2 upon 4 plus D3 upon 8. So what will happen if my D1 is 1 and my D3 is 1? What will be my gain then? What will the gain be? Acha, let me put my D0 is also 0 and my D2 also 0. The gain in that case will be V output is equal to V in 1 plus 1 upon only D3 is 1. So it is 0 plus
9.
plus 1 by 8. It is V in into 1 plus 8. So your V out will be equal to 9 into V in. Okay, as Sangeeta said. Okay, NS, I think you got confused a bit. I think you got a bit confused. Oh, yeah. I think I sort of assumed that in my question. And then I changed. Okay. So then we will consider what is known as a instrumentation amplifier. So first of all, it is a two-stage amplifier. And we use it because it can give very high input impedance. That is why we use it. So is there any problem when we use single stage amplifiers? Then we are going for two-stage amplifiers. So what are the single stage amplifiers we know? We know what is the non-inverting amplifier and the inverting. Let us consider an inverting amplifier in this case. So this will be connected to ground. This is your R1. This is your V in. and this is your R2. This is your V out. So as this negative feedback, so virtual short concept is applicable. Okay. So your current I, which will flow, and this will be like at 0 volt at ground potential. So your I is equal to V in upon R1. So your input impedance or your input resistance, which is equal to your V in upon I, is equal to R1. Okay. So this is not infinity. This is not infinity. It is dependent on R1. And can we make R1 to be very, very high? We cannot make, because my gain is equal to minus R2 by R1. So if I want high gain, what I should do? I should either increase R2 or I should reduce R1, or I should do both. So what we should do is we should reduce R1 and we should increase R2. So what we want when we want high gain is we have to reduce R1. But if we reduce R1, what is happening? The input resistance is becoming low, and that is not what we want. We want input resistance to be high. So this is creating like a conflict. Okay. So that is one issue. So now, to overcome this issue of single stage amplifiers, they use two-stage amplifiers, the instrumentation amplifier. And it is a combination of difference amplifier and this other and another two set of amplifiers. Okay. So we will look at the circuit and we will try to analyze the circuit. So it has two stages. This is one stage which has two amplifiers, and there's a final stage. Okay. There is one resistor here, another resistor here, another resistor here. Both cases, there's negative feedback. Let us say this is your R3, this is your R4. This is your V positive supply. Or let us say this is your V input. Your V input is applied across this. Okay. That means this is your V input positive. This is your V input negative. Okay. Now, this will come over here. Sorry. There'll be some resistors. So you will have certain resistors over here. Let us say this is your R1 and this is your R2. Okay, so this is simple. This is your second stage. This is your stage 2. And it is a difference amplifier. So if this point was, let us say A, and this point was B, so your V out is actually minus R2 by R1 into VAB. Okay. That is your expression of V out. This is very simple. Now we must consider the first stage. The first stage is a little bit challenging, but sir explained it very well. And hence it is a little bit easy to understand. First, you must notice that we are always in the entire circuit, in each of the op-amps, we are using negative feedback. And what is the feedback signal? Over here, this signal is coming over here. And this signal is coming over here. And sir also showed how actually this is negative feedback. So what we can assume is the virtual short. Virtual short principle is being followed. That means the voltage over here is your V in positive. And the voltage over here is your V in negative. Okay, that is one thing. Next, we know ideally the current into the input terminal of the op-amp will be 0. Okay, the current will be 0. So let us assume there's some current I which is flowing here. Your I is actually V in plus potential over here minus the potential over here by R4. This is your current I. Now, what is the current flowing over here? How much is the current?
Zero, sir.
Yeah. This current will be 0. This current also has to be 0. So that means this current I has been flowing from here itself. I will flow till here. Okay. So your current I can be written as VA minus VB divided by the resistors R3, R4, R3. So it is R3 plus R4 plus R3. So your current I is actually VAB upon R4 plus 2R3. But we know your current I is also equal to V in upon R4. Okay, this is equal to V in upon R4. So my VAB is equal to R4 upon R4 plus 2R3 into Vn. Okay, this is the first stage. Sorry. It is R4 plus 2R3 upon R4. And what is my V out? It is minus R2 by R1 into VAB. So it is minus R2 by R1 into R4 plus 2R3 upon R4 into Vn. So this is my overall gain which we are able to achieve. Okay. And it is divided into 2 stages. Okay, we are getting that gain and we want high input impedance. So how much is the current flowing in? How much is the current flowing into my amplifier, into my overall setup of the amplifier? How much is the current which is flowing in? Can you tell? Hmm? So how much is this current?
ये तो जीरो होगा ना सर?
Zero होगा, zero होगा. So your input impedance is equal to V in upon 0. That is what? Infinite. So we are getting both what we want. We are going to get high gain as well as we are getting high input impedance. Okay, so this is the advantage of this. So any doubts in this?
ये सर इसमें माइनस साइन वाला बाय एक्सप्रेशन आया है ना सर?
हाँ.
यस.
That is the equation of your difference amplifier. Okay.
ओके सर. ओके सर.
Because this A is coming to a negative terminal and this B is coming to a positive terminal. So this is effectively your VAB, right? And because VA is at the negative and B is at the positive, that is why you get VAB is equal to V out is equal to minus R2 by R1 into VAB.
ओके सर. प्रोसीड.
So if there are no questions, then we can start with the assignment questions. Okay. So I'll start. So we will solve the assignment questions. Okay. First question. So this is the circuit which is given to us, and they have told that this voltage is 2.9 volt. So your PMMC instrument is showing 2.9 volt. Then what is your V in? Okay. What is your input current in this state? How much is your input current? So how will you solve this? So first of all, there's negative feedback. So we will consider the virtual short ground concept is valid. Okay. And let us say this your plus minus your V input. Huh? So whatever plus V in is over here, it will also come over here. So over here also it is V in, right? Your V in. Now, what is this is a non-inverting. This is a non-inverting amplifier, right? And this is the V out. So what is the relation of V out to V in? V out is equal to how much into V in? What is the expression?
1 plus R2 by R1.
So it is 1 plus R2 by R1 into V in. Okay. So what is your R2 in this case?
98 kilo.
Your R2 is 98 kilo ohm. What is your R1?
2 kilo ohm, sir.
2 kilo ohm. Right? So what is your V out in terms of V in?
$50, sir.
So your V out is actually equal to 50 into V in. Okay, I found V out is equal to 50 into V in. But they are telling to find I in. How will we find I in now? Input current, how will we find I in?
V in by 1 ohm.
Yes. So my I in actually is equal to V in upon 1 ohm. Because the current which flows here has to flow here and over here. Over here, no current will flow. No current can flow over here. It has to flow like this because the current into this has to be 0. And if the current here is 0, current over here also is 0. So this current has to go like this. Now, current cannot come like this because it has to obey KCL. If it is obeying KCL here, let us say this is IX. The current here in this branch is IX. So your IX is equal to I in over here. And let us say this is current is IY. Okay. So over here, what will happen is I in is equal to IX plus IY. For both these equations to be valid, your IY has to be equal to 0. Okay. So current cannot arbitrarily flow. For current, it is very important that there should be a closed path. It should start from one point of the circuit and it will end again at that point of the circuit. If it is not closed, your current cannot flow. Okay, so that is why we can say with confidence that the input current will only pass that 1 ohm resistance and come out. Okay, but keep in mind this is for an ideal op amp. In reality, when you will be doing your practicals and experiments, there will be some deviation because some leakage current will be there, but they are negligible. Okay, so now your V out is equal to 50 into 1 ohm into your I in. So your I in is equal to 50, V out by 50. V out, they told it is 2.9 volt. So how much is your I in? $58 milliampere. Okay, it is actually 58 milliampere. So if you do the calculation, you will get this answer. Then another thing I'd like to know, what is this circuit actually doing? It is used to measure current. And that current information, it is measuring using what? What is it actually measuring? What instrument is it using for measurement? It is using a PMMC. And that PMMC, is it an ammeter or voltmeter?
It is a voltmeter.
Yeah, it is a voltmeter. But what we are doing is, through this circuit, we are measuring current using a voltmeter. So we are actually doing this circuit is basically what it is doing. It's a current to voltage converter circuit. Current to voltage circuit. So the current information is converted into a voltage. That voltage information comes at the output, and that is measured using a voltmeter. So current information is converted to a voltage which is proportional, and it is fed. Okay. So this is used in many circuits. Okay. And what is the internal resistance of this circuit? The input resistance of this circuit. What is the input resistance of this circuit?
Input resistance is 1 ohm.
Yeah, the input resistance is 1 ohm. Okay. Now, this is like kind of like an ammeter. Like it is kind of measuring current, although it is telling it in terms of voltage. Its goal is to measure current. Now, in all the traditional circuits which you studied till now, we were using ammeter. An ammeter was used to measure current. So what should be the internal resistance of an ammeter ideally?
Ammeter 0 resistance.
It should be 0 ohm. But now, using this op amp circuit, we are getting internal resistance of 1 ohm, which is very, very close to 0 ohm. It is not exactly 0 ohm, it is close to 0 ohm, but we are able to achieve very low internal resistance. But in the actual ammeter, your input resistance will not be 1 ohm, it may be more than that. Because you have a coil, it has turns, and when there are turns, then there will be resistance, there will be inductance, all that will come. Okay, but through this circuit, we are kind of mimicking how an ammeter works, and we are generating some voltage. Okay, we are able to generate a voltage proportional to the current, and we are also able to make the input resistance very low. So this is one example of how we can do certain manipulation. We are converting signal information to some other information so that we can use it. Okay. Now we will go to next circuit, which is given by this. So if you look at this circuit, it is very scary. When I looked at the circuit also, I was so scared. Like, what is this circuit? How am I going to solve this complicated circuit? Okay, so let us break it down step by step. First of all, notice it is okay. Let us note down what they have asked us. In the above electronic voltmeter circuit, the full scale deflection current of the PMMC meter is 2 milliampere and its coil resistance is 500 ohm. The forward voltage drop of the diodes is 0.7 volt. Okay, so we have this is a PMMC ammeter. Its maximum range is 2 milliampere and its internal resistance is 500 ohm. And the forward voltage drops of these diode, each diode, when it will conduct, it will have a drop of 0.7 volt. Okay, so will that create an error in our measurement? We will see. So now my input is shown to be sinusoidal. So there will be some input current. Okay. What is the equation of my input current? Can you tell me? Okay, input current is 2 milliampere. Not exactly. Okay, but we will start. So what we must know is, first of all, there's negative feedback. Okay, and this is inverting amplifier. So over here, what is the voltage? 0 volt. By virtual short concept, voltage over here is 0 volt. So my input current is what? V in upon this resistance. Okay, V in upon this resistance. This is my input current. Now, this current cannot flow over here. Okay. Into the op amp, the current is 0. So this input current has to flow like this, right? So suppose this is my voltage. And my input current is like this. Okay. When my input current is positive, it will flow like this, like this, like this, and like this. It will complete the circuit. But when my input current is negative, that is what to say the input current has gone negative. It would have become like this. Then the current has to flow like this. It has to come like this, and will come like this, and come like this. So the rectification is happening to the diodes. So the current over here, this current Ix, the current Ix will be like this. Okay, this is the current Ix. Any doubts so far?
सर इसमें नेगेटिव फीडबैक के माध्यम से सर
क्योंकि जो आउटपुट का इंफॉर्मेशन है वो यहाँ पे आ रहा है ना, और वो नेगेटिव टर्मिनल में आ रहा है। भले ही कुछ तो रेसिस्ट डायोड के थ्रू वैसा कुछ है, पर इफेक्टिवली उसका इंफॉर्मेशन आ रहा है। तो क्या होगा अगर आउटपुट बढ़ेगा? अगर आउटपुट थोड़ा बढ़ेगा उसका मतलब क्या होगा, जो इनपुट इधर वोल्टेज है वो भी बढ़ेगा, और जब भी वो बढ़ेगा VP और माइनस VN वो कम हो जाएगा। तो जब भी VP माइनस VN कम हो जाएगा, आपका आउटपुट वोल्टेज वापस कम हो जाएगा। तो इसलिए वो आपको स्टेबलाइज कर रहा है, वो नेगेटिव फीडबैक हो गया।
यस
हम्म, ठीक है। तो एनी डाउट स्टिल हियर?
सर, और एक क्वेश्चन है सर। जैसे उसमें एक मतलब पीछे में जो आप बता रहे थे उसमें नॉन इन्वर्टिंग एम्पलीफायर ये जो किए थे सर
हाँ हाँ हाँ, अभी इन्वर्टिंग एम्पलीफायर।
शुरुआत में। यस सर।
हाँ, बस वो इन्वर्टिंग नॉन इन्वर्टिंग एम्पलीफायर को इन्वर्टिंग एम्पलीफायर करके लगा दिया है। हाँ, ठीक है। तो अभी my input current is given by V in by R. So this is my I in, and red one is my V in, and purple one is my IX. So they are told that a PMMC ammeter reads 2 milliampere. What is this 2 milliampere? That is the average value of this. Okay, and this, let us say this is my I peak. So your IX average will be 2 upon pi into I peak. Okay, 2 upon pi into IP. Now, this current I in and this is same over here. So this is also I peak, right? And we know what I in is. I in is V in upon R. So IX average is actually 2 upon pi into V peak upon R, right? So then IX average is equal to 2 upon pi R into what? Your V peak actually is equal to root 2 into V RMS, right? So your V RMS is equal to pi into R on 2 into root 2 into IX average. So your V RMS is equal to pi into R is 25K upon 2 into root 2. IX average is 2 milliampere. So into 2 into 10 to the power minus 3. So what will be my V RMS? Can anyone calculate and tell me?
$17.6.
How much?
फिफ्टी 5.50।
Yeah, it is 55.5. It is?
Yes, sir. 55.51.
Yes. It is 55.5 volts. Okay. So the next part of the circuit, what they're saying, if the meter shows 50% deflection, that is, it shows half. If it shows half deflection means what? Instead of showing 2 milliampere, it will show 1 milliampere. Then what your answer will be? It will be 27.25 volt. 2 is becomes 1 milliampere. So then the voltage also will change. Accordingly, it will change. So there is nothing difficult in that. I'm skipping that.
यस
Next is estimate the input resistance of the electronic voltmeter circuit. So what is the input resistance of this circuit? In this circuit, what is my input resistance? What is the formula for input resistance?
V in by I.
Yeah, so your input resistance is equal to V in by I in, and that is equal to what? It is given here, no? V in by I in is R. So that is R. That is your 25 kilo ohm, right?
Yes, yes.
Okay. So we'll proceed to the next question. This circuit.
सर ये तो दिया ही हुआ था 25 किलो ओम फिर.
हाँ सही है, तो है 25 किलो ओम तो है. That is correct.
अच्छा वही पूछ रहे थे, मतलब ऐसे ही पूछने के लिए दिया है, मतलब कैलकुलेशन करने का.
हाँ, मतलब आप ये सिर्फ पूछने के लिए नहीं, आपका अंडरस्टैंडिंग, आपका जो समझ में आया ना आपको, वो चेक करने के लिए मैंने ऐसा क्वेश्चन पूछा.
Yes, sir.
Okay, so now is it audible?
Yes, sir.
Yes.
Okay, sorry. So what actually happens is your measured current, they have told is 16 milliampere, and your resistance of your PMMC is 450 ohm. Your forward drop of your diode is 0.7 volt, and this is working as a half-wave rectifier. So what happens is your input current is given by Vin upon 5. This only happens when your Vin is positive. If your Vin is negative, then the diode becomes reverse biased and current cannot flow. Okay. So this is your input voltage. This is your input current. Input current will have a peak. Input current flows only when your input voltage is positive. When your input voltage is negative, it is 0. And then again, when it is positive, it again flows. And that is given by Vn upon 5 when your current will flow. And your average value of your current is given by I peak upon 5 because this is a half-wave rectified value. And your I peak is given by V peak upon 5. Similar thing what we did last time. So your I average is actually equal to V peak upon 5 into 5. Right? And this is equal to root 2 into VRMS upon 5 into 5. So your VRMS is equal to 5 into 5 into I average upon root 2. Okay. So your average current is given by 16 milliampere. So what is your VRMS? Your VRMS is 5 into 5 into 16 into 10 to the power minus 3 upon root 2. So can you calculate how much is it?
Zero point one low 7.
0.17.
So it is 0.177 volt. Okay. So now we got the RMS value. So that is one part of the sum. Now the next part of the sum is the tricky one and it's a challenging one. What happens is, suppose my input voltage is increased, then my input current also will increase. But can it go as high as I want? Can it flow as high as I want? It cannot flow. Okay, it cannot flow. Because what is your output voltage? Can you tell what is your output voltage? If you draw, your output voltage is dependent on how much current is flowing over here. So this voltage is 0 volt through virtual short concept. So your V output from here, if I'm flowing V output is equal to I into R of PMMC plus V, the drop across the diode. So your V output is equal to I in into R PMMC is 450 plus the drop across the diode is 0.7 volt. Okay. Your V output maximum can be 15 volt. Cannot go more than it. So if your input current is increasing, your output voltage can increase as long as it is within 15 volt. If it goes above 15 volt, then this relation is not valid. There will be some change. Your current will not flow, or it may get clamped. Okay. So now, this is my peak, 15 minus 0.7 is the input current into 450. Now, this input current is not the actual input current. It is the peak. When your current is at the peak, how much it can flow. Okay, that is the current. So that is 14.3 is equal to I peak into 450. So your I peak current will be 14.3 upon 450. How much is that?
0.031.
0.03.
So it is actually 31.77. Sorry. 31.77 milliampere. Okay. So this is the peak current that can flow. And based on that, we can calculate the RMS current, etc. It's fine. Okay, so this sum also is done. So we will go to the next question. So this is the circuit. Okay. They're saying to PMMC voltmeter reads 0.5 volt, estimate the RMS value of the input voltage, assuming it to be purely sinusoidal. So this is again another simple circuit. So this is again like a half wave rectifier. And this is also known as a precision rectifier. So because of virtual short concept, this voltage is also V in, right? So what is this voltage V out? Your V out is equal to 1 plus R2 by R1 into V in. So your V out is equal to 1 plus 7 upon 1 into V in. So it is 8 into V in. Okay, your V out is 8 into V in. Now your V out average, they are saying, is 0.5 volt. Now, this is your input voltage. Okay, your V out will be like this, something like this. Because it is 8 times, this is your V out, this is your V in, right? So it will have some peak. This will have some V in peak, which is equal to your V RMS into root 2. So your V in peak is equal to V peak upon 8, and this is V RMS into root 2 is equal to V peak upon 8. So your V RMS is equal to V peak upon 8 root 2. Now what is your V peak? Your V output average is equal to V peak upon pi. This implies your V peak is equal to V output average into pi. Your V RMS is equal to V output average into pi upon 8 root 2. So your V RMS, your V output average is 0.5. So 0.5 into pi upon 8 into root 2. What is this value?
Zero point 31.
0.3.
31. 13, sir. 13. 13.
Okay, 0.13 volt. Okay. So now we'll consider this circuit. They're telling us to find out the current. They're telling us to find out what is VAB and VOut. Okay, this is a simple circuit.
ये 2 स्टेज वाला है ना सर?
हाँ, ये 2 स्टेज वाला है.
2 स्टेज है.
Okay. So first they told we have to find I, we have to find VAB, we have to find V output. So what is I? What is the value of I? How will I find?
I means the input current, sir.
Input current. This is the input current.
VB माइनस VC करेंगे सर बाई 4 किलो.
क्या? I is actually VB minus VC by 4 kilo ohm. Correct. What is your VB?
0.25 volt, sir.
And what is your VC? No, actually it is your VB minus VC is 0.25 volt. Okay. So VB minus VC divided by 4 kilo ohm. So how much is your current in milliampere? Hmm?
0.62, sir.
It will be 0.062. It will be 0.0625
Right, sir.
milliampere. Okay. Now what is your VAB? How much is your VAB? Oh, this is they have made a mistake. This is also B, this also cannot be B. So let us say this is Vx. Okay, so how much is your Vx? Hmm? We just
VA minus VD by
yes.
16 kilo ohm.
Vx minus Vd by 16 kilo ohm. No. Your Vx is this same current I will flow here. Same current I will flow here. That is I into 6K plus 4K plus 6K. So
Right,
Vx
sir.
is 0.0625 into 10 to the power minus 3 into 16 into 10 to the power 3. How much is it? 1 volt. Okay, that turns out to be 1 volt. Right. Now, what should be my V output? How much is V output? So this is a difference amplifier. And what is the gain of this difference amplifier? Your gain of the difference amplifier is minus 3K upon 3K into your Vx, into your input. So that is equal to minus Vx. So your V output is equal to minus 1 volt.
Okay, sir.
Okay. Yeah. So now we can look at some simulations. First, let's start with the inverting amplifier. Okay. This is my inverting amplifier. So the positive terminal is connected to the ground. And this is my R2, this is my R1. So what is the gain of this inverting amplifier? What is the gain?
minus 100 by 10, then minus 10.
Minus 10. My input
Right.
is a sine wave, which is amplitude of 1 and frequency of 10 kilohertz. Okay, minus 10. So now, let me run it for some time. So this is my input. My input changing from 1 to minus 1. Okay, this is my input signal. How should my output signal look like? How should the output signal look like? It should be, yes, it should be inverted and bigger. So my output signal will look like this. Output signal vary from minus 10 to plus 10, and it will be out of phase because it is negative gain, right? Minus 10. So it is 180-degree phase shifted. Okay. So this is how I can see my output and input, and how they are varying with time. And so it is working as an amplifier with the gain we want, and as an inverting amplifier because it is flipping the sign, flipping the polarity of your signal. Okay. Any queries in this?
सर इसको रिपीट कर दूं सर.
हाँ, ठीक है. तो पहला मेरा इनपुट वोल्टेज वो 1 to -1 जा रहा है. हाँ, 1 से
राइट
माइनस.
सर.
और मेरा गेन मुझे मालूम है 10 है. R2/R1 10 मैडम बोल दिया. ठीक है. मेरा वी आउट कितना जाना है? 1 into 10. तो 10 से -10 जाना चाहिए. और पर एक और बात याद करना है कि ये एक इन्वर्टिंग एम्पलीफायर है. इन्वर्टिंग मतलब क्या? वो पोलैरिटी को रिवर्स कर दे. तो जब भी आपका इनपुट पॉजिटिव रहेगा आपका आउटपुट नेगेटिव रहेगा. जब भी आपका इनपुट नेगेटिव रहेगा आपका आउटपुट पॉजिटिव होगा. ठीक है. तो मैं यहाँ पे आउटपुट देखूंगा. आउटपुट कितना आ रहा है? मेरा आउटपुट भी अगर देखोगे 10 वोल्ट से -10 वोल्ट जा रहा है. तो वो मेरा कैलकुलेशन के हिसाब से सही है. वो हो गया. अभी मैं देख रहा हूँ जब भी मेरा इनपुट नेगेटिव है तभी मेरा आउटपुट सबसे ज्यादा पॉजिटिव है. जब भी मेरा इनपुट सबसे ज्यादा पॉजिटिव है मेरा आउटपुट सबसे ज्यादा नेगेटिव है. ठीक है. तो वो साइन को फ्लिप कर रहा है, इसलिए वो इन्वर्टिंग एम्पलीफायर बोला जाता है.
तो थोड़ा सा विजिबल नहीं है इसीलिए सब समझ में नहीं आ रहा है और दिख नहीं
इसमें
रहा
नहीं है
था.
क्या? अच्छा. अभी
आउटपुट हो रहा था. यस. यस सर. यस
हाँ,
सर. ठीक है सर.
ये
हो गया सर.
होता है. ठीक है.
यस सर.
So now we will check the non-inverting amplifier. So in this case, what is the gain? इधर gain कितना होगा?
11.
Yes, the gain should be 11. Okay. Suppose I want the gain to be 10. So what should I change? How much should I make R2 if I want the gain to be 10?
It should be 90 kilo.
Yes. So I make it 90 kilo so that my gain is 10. Now I will run it. Showing. So this is my input. Okay. So my input is changing from 1 to -1. My output also should change from 10 to -10. And when my input is positive, my output also is positive. When my input is negative, my output also is negative. So that is why it is a non-inverting amplifier. It is in phase. The output is in phase with your input and with that gain which we calculated. Okay. Let me make this bigger. Yeah. And great. Okay, so now is this clear?
Yes, sir.
Okay, so this is part for a non-inverting amplifier. Now, let's consider non-inverting rectifier. So again, let me go for a gain of 10. So now I have an input is AC, but I want to make it DC. So I use a diode. So, okay. So this is a half wave rectifier. So let me run it. So this is my input voltage. It is positive, etc. And this is my output voltage. So you see this. Okay. Now both can be seen side by side. Okay. Now is it clear?
ठीक है सर अभी
Okay. So this is how, but there is a problem. You see, it should be positive, but it should go to 10. But it's not going to 10, it is going to 9.1. And why do you think that is happening?
डायोड वोल्टेज ड्रॉप सर
Yes, because of the drop due to the diode. It is happening. Okay. So, and do I want it? I don't want that because that will change my calculation. That will introduce an error. So we do not want this sort of problem. So what we do then, we'll go to the next circuit. That is my precision rectifier. Okay. Just let me make it 90K. So this is a similar circuit, only the diode I have moved from here to here. That's the only change I have made. Now I will run it. Okay. It's showing blue. So let us see the input voltage is looking like this. From 1 to -1. The output voltage is looking like this. Okay, let me uh, the output. Okay. So now it is going to 10 volt. Earlier it was not going to 10. Now it is going to 10 volt. Oh, let me change the color. You were saying this color is not good, right? Now is it visible?
Yes, sir.
So this is how we have checked our concept. Okay, how it is happening. Now, one more thing which I also want to see is, okay, I want to see what is the diode, what is the voltage over here. Okay, so this is the voltage across the diode. So, okay, now is it better?
Yes, sir.
Now, this is a voltage VVOP. Is the voltage where? Over here at this point. And what is the voltage across the diode is what I want to check. Okay, so now is VVOP minus VVOut. So this is the voltage across the diode. So when the diode is conducting, it is at 0.7 volt or something, some value. Okay. Around 660 millivolt. Okay, 660 millivolt. And when it is not conducting, it is reverse bias, some negative voltage is applied across it. Okay, negative voltage is applied. And why is that? Let me add something below. So what is happening is, sorry, this is the output of your op amp. So when your input is negative, your op amp will saturate at a negative value. So it'll be minus 12 volt, minus some voltage. Okay. This is a negative voltage is or at the output of the op amp. That is the voltage over here becomes minus 12. And so your op amp becomes, so your diode becomes reverse bias. It will not conduct. So any other queries?
पहला वाला क्वेश्चन पर स्लाइड सर,
कौन सा?
फर्स्ट क्वेश्चन, पहला क्वेश्चन सर,
पहला क्वेश्चन
फर्स्ट क्वेश्चन।
अच्छा, पहला क्वेश्चन वापस बोलो, ठीक है। Now okay, yeah. The white background is good. I know, but it is not a default. I'll have to change it to my default so that I can use it. So in the first question, क्या था? हाँ, yes. तो पहला क्वेश्चन में क्या हो रहा है कि जो भी करंट फ्लो हो रहा है ना यहाँ से, वो मेरा वोल्टेज जनरेट कर रहा है। मेरा Vn इज इक्वल टू माई In. तो यहाँ पे भी प्लस माइनस Vin है, वर्चुअल शॉर्ट है, तो यहाँ पे तो आज समझ लो यहाँ पे Vn आ गया, यहाँ पे Vn आ गया, ठीक है। और ये कौन सा एम्पलीफायर है? ये नॉन इन्वर्टिंग एम्पलीफायर है। तो उसका वी आउटपुट इज इक्वल टू 1 + R2/R1 × Vn। हाँ, तो मेरा वी आउटपुट इसी हिसाब से आ गया, तो मेरा वी आउटपुट हुआ 50 इंटू वी एम। अभी इस हिसाब से मेरा आई इन भी मिलेगा मेरे को वी आउट बाई 50, और मेरा वी आउटपुट एवरेज वैल्यू दिखा है 2.9, तो 2.9 बाई 50 इज 58 मिली एम्पियर।
ठीक है सर, हो गया सर।
ठीक है। Okay. So I'll just do a brief recap. So we first studied why do we need an electronic instruments? Why not always an ammeter, voltmeter can exactly work? Why we sometimes need amplification? Then we studied a non-inverting amplifier. What is the gain? How the waveforms look, which we also saw using the LTSpice simulation. Then if there's an AC voltage and we want to use a PMMC because of its linear scale, welcome. Then what we will do, we'll have to use a half wave rectifier or a full wave rectifier. So the output, the equation for a half wave rectifier is given by this, and the equation for a full wave rectifier is given by this, and then it is given by V peak, but V peak has to be converted to RMS, right? So that is how we can get the RMS voltage in terms of voltmeter reading. Then how we can change the position of the diode, and then we can see the output. So this was also shown in the LTSpice simulation. So what was the output over here? What is the signal over here? What was the input signal we saw? Okay, what was the actual drop? What was the diode also we saw? All these we saw. Okay. Then programmable amplifier also is something we can do. If you want the gain to be programmable, we have to vary my R2 and R1. Okay, so how do we vary R1? There's some circuit is possible. Okay. Then we consider what's an instrumentation amplifier, how it's a two-stage amplifier, it should have high input impedance, how it is not possible with a single-stage amplifier, and then how we derived this, and we also solved a sum later, the last sum. It's just based on, so if we know this derivation, we can solve the last sum. So the goal is to understand the derivation, to look at the circuit, derive the conditions, and then you can easily solve the questions. You don't need to remember it by heart. Okay. Then the assignment, this current to voltage converting signal, converting circuit. Then this full wave rectifier based circuit we did. Then we saw this half wave rectifier based circuit we studied. And what should be the maximum value of current also we found. Then this also is the precision rectifier circuit. And then this is the instrumentation amplifier circuit. Those some we saw. Okay. And then at the end, we saw LTSpice simulation. Okay. So I hope you guys understood this concept, that this session was able to, reinforce or strengthen the concept which sir has taught throughout the week, that we could solve some sums which will help you in solving your assignments, as well as we did some simulations which will help you to, visualize, to see, and to believe that this circuit works actually. Okay. So any questions?
No sir.
Okay. So if there are no questions, I will end this session. Okay. Thank you for joining.
Thank you sir. Good night sir.
Good night. Thank you. Okay. You're welcome. Good night. Bye.